Now we'll move on to the verification of the logic gates. First is AND gate. So when you have two inputs, you will have four combinations, that is 0 0, 0 1, 1 0 and 1 1. That is, both the inputs can be off condition or both the inputs can be in on condition, or one can be in on and one can be in off. So when you consider the AND gate, so the output is y is equal to a into b. So it is a multiplication operation. So when you see your outputs, here when 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0. So only when both the inputs are 1, your output you will get a output. Now we'll move on to the OR gate. OR gate is 1 a plus b. That is, when either of the input is 1, you will get the output, or when both the inputs are 1, you will get the output as 1. When you see both the inputs are 0, it is 0. So if you see 1 plus 1 in boolean, it is 1, or 1 plus 0, it is 1. It just operates with the just an addition function. Now we'll move on to your NOT gate, which is also known as inverter. If I'm going to give the input as 0, your output will be 1. If I'm going to give the input as 1, output will be 0. Now we'll move on to your NAND gate, which is just the opposite of your AND gate. That is, AND gate after followed by an inverter will give you an AND gate. So the expression is a dot b the whole bar. So now we'll move on to the expression. So in this NAND gate, you will get the output if you'll get the output as 0 when both the inputs are 1. When both the inputs are 1, your output will be 0. For all other condition, it will be 1. It is just the inversion of your AND gate. Now we'll move on to the NOR gate, which is just the inversion of your OR gate. In OR gate, what happened? If any of the input is 1, output is 1. But whereas here, when both the inputs are 1, output will be 0. For all, when both the inputs are 0 alone, your output will be 1. For all other conditions, output will be 0. Now we'll move on to your XOR gate. XOR gate is 1. When either of the input is 1, you will get the output. That is for the second and third condition. When it is 0 1, you will get the output as 1. 1 0, output as 1. All other outputs, the output will be 0. Now we'll just see the connections and see the verification of the gates in the kit. Now this is the kit where you have the input, that is 2 input AND gates, 3 input AND gates and 4 input gates connections are there. And here you have a counters for doing your counters. Each is a flip-flop. When it is going to be connected in series, it can be used for the counter operation. Now just you on the circuit. Now we'll verify your AND gates. You just have the 2 inputs. You have a 2 input AND gate. So now 2 connections are given. And here this is the set of inputs, switches, whereas this is a set of LEDs for showing your outputs. You have the gates, you have the inputs, you have the outputs. Now these are the 2 inputs that has been connected to the first 2 points, and this is a point for the output. This orange color wire shows the output here. Now we'll just verify the AND gate. So what is the operation of the AND gate? When both the inputs are 1, your output will be 1. For all other condition, it will be 0. So for 0 0 it is 0. For 0 1 it is 0. 1 0 it is 0. For 1 1, for 1 1 condition alone, the LED glows. Okay. Now we'll move on to the second gate, that is the OR gate. You have the 2 inputs are being connected from the OR gate, and it is given as the input here, and the output is shown by the green wire, which is the second LED. Now what is the function of the OR gate? If either of the input is 1, your output will be 1. So now first condition is 0 0, so the light doesn't glow. When it is 0 1, the light should glow. When it is 1 0, the light should glow. When it is 1 1, the light should glow. This completes the OR gate. Now we'll move on to the NOT gate, where the NOT gate input is given to this pin and the output is given to this LED 8. Now I am owning this, that is whenever it is in low condition, it is output is 1. Whenever it is 1, the output is 0. You can just analyze once again. When it is 0, it is an inverter, so it inverts the output. 0 means 1, 1 means 0. This completes the NOT gate. Now we will move on to the NAND gate. So NAND gate is 1 here. These 2 wires are connected to the NAND gate. Now what is the output of your NAND gate? When both the inputs are 1, your output is 0. For all other conditions, your output is 1. So when both the inputs are 1, let us take the condition. When Either of the inputs is 0, you have the output as 1, 0 1 also 1, 1 1 also 1. When both the inputs are 1, your output is 0. Once again, I'll tell you the connections. When both the inputs are 0, output is 1. I'll off the other lamps. When both the values are 0, output is 1. For 0 1 condition, it is 1. For just check the LED 5 alone. For 1 0 condition also it is 1. For 1 1 condition alone, this LED goes as 0. Now we'll move on to your NOR gate. NOR gate. Now these are the two inputs for your NOR gate. In NOR gate, you have when both the inputs are 0, the output is 1. You can check the LED 3. Now whenever it is 1, it is off, or 1 0 it is off, or 1 1 it is off. So only when both the inputs are 0, you can see the LED glows. So this completes the function of your NOR gate.